Okay, in this next video we're going to start looking at some proofs. We're going to fill in missing information. It's not a full proof by itself. This is actually a flow proof. You should have seen some of these when we were doing proof days. Given that SQ bisects angle PSR and angle P is congruent to angle R, prove that the two triangles are congruent. Well, SQ bisects angle PSR. That's given. Now that leads to, that's what the arrow means, it leads to this statement here, angle PSQ, so angle PSQ is congruent to angle RSQ. That's the definition of angle bisector. Because it cuts it in half, those two angles are equal. Angle P is congruent to angle R, that was given. Notice how it's stacked, 1, 2, 3. Those three things should lead to the two triangles being congruent. There's two. The third one, SQ, is congruent to itself. That's the reflexive property. So now I have the two triangles are congruent. Why are they congruent? Angle, angle, side. So that one we're just supplying the reasons in the flow proof. Okay. Number 15, fill in the missing reasons. Again, all right, so PQ is perpendicular to QS. RS is perpendicular to QS. Okay. T is the midpoint of PR. So PQ is perpendicular to QS. RS is perpendicular to QS. That's given. What does that mean? Well, it means angle Q and angle S are right angles. Now that technically could be given because it's in the picture, but I think what they're trying to get to is that that's the definition of perpendicular lines. In this case, it could be given, though. Okay. Angle Q is congruent to angle S because all right angles are congruent. They're right angles, they're also congruent. Okay. The reason for number 4 is vertical angles are congruent. So I'm looking at the vertical angles. That would be these. And I'm going to say that they're congruent. So angle QTP is congruent to angle STR. T is the midpoint of PR. We knew that. That means PT is congruent to RT because of the definition of midpoint. That's enough. That's three things to say that the two triangles are congruent. So triangle PQT is congruent to triangle RST because of angle, angle, side. Okay. Another flow proof on the back. Fill in the reasons. QR is congruent to SR. I'm going to go ahead and mark that. TR bisects angle R. Now that shouldn't say angle R. That should technically say angle QRS. Okay. We're going to prove that angle Q is congruent to angle S. So QR is congruent to SR. That's given. TR bisects angle QRS. That's also given. Okay. Angle QRT is congruent to angle SRT. QRT is congruent to angle SRT. That's the definition of angle bisector. And then TR is congruent to itself. That's the reflexive property. Okay, so now I can say that the two triangles are congruent because of side, angle, side. Again, if you have a hard time seeing that, redraw one of the triangles. Q, T, R, mark the things that we marked congruent, sides, two sides, and the angle between them. That's side, angle, side. And then because the two triangles are congruent, angle Q and angle S have to be equal because of CPCTC. Okay. The next several are from the Isosceles Triangle Theorem and its converse. And so we'll do that, and then we'll be done with this video. The base angle of an isosceles triangle measures 48 degrees. Find the measures of the other two angles. Well, the base angles of an isosceles triangle, I'll just draw one real quick. If this is an isosceles triangle, that means two sides are the same. The base angles are these down here, the ones that are across from the two congruent sides. They do not always be on, they're not always on the bottom. So let's say we had a triangle like this, where this and this are equal. The base angles would be here and here. Well, if one of them is 48, the other one has to be 48. So one of the angles is 48. Well, if they're both 48, what's left is the vertex angle, and that would be 48 plus x equals 180. 48 and 48 is 96, and that would leave 84 for the vertex angle. Okay. The measures of the angles in triangle ABC are there, there, and there. Draw a triangle ABC, mark all congruent parts, and classify the triangle by its sides. So, not drawing this to scale, I'm just going to draw angle A, B, and C. So A is 3x minus 12. B is x plus 8. C is 2x plus 16. Those are all going to add up to 180. So 3x, 4x, 6x. Negative 12 plus 16 is 4. 4 plus 8 is 12. So 6x, subtract 12, I get 168. X equals what? 28, I think. Yeah, x equals 28. So now I can figure out angle A, angle B, and angle C by just plugging in 28. So 3 times 28 minus 12, 28 plus 8, and 2 times 28 plus 16. So 3 times 28 is 84. Minus 12 is 72. Angle B is 36. Angle C is 56 plus 16, which is 72. So angle A and angle C are congruent, which means AB is congruent to BC because of the converse of Isosceles Triangle theorem, which says if the two angles are congruent, then the sides across from them are also congruent. And this is an isosceles trapezoid. Sorry, not trapezoid, getting ahead of myself. An isosceles triangle. Okay, there you go. Notice I said isosceles, that's classification by sides. If I was classifying by angles, it would be acute, but that's not what I asked. Okay. 19 through 22 is using all isosceles triangles. So you've actually done this one on the notes. Shouldn't have to do it again, but I'm going to. There's multiple ways of doing this. This is 70. This whole thing is a right angle, which means this angle up here is 20. The reason I know that, 70 plus 90 is 160. 180 minus 160 is 20. Well, this triangle here is isosceles, so this angle and this angle have to be equal. So this is 20 as well. So x plus 20 plus 20 equals 180. And again, if this is not the way you did it, that's okay. There are at least 2 other ways that I can think of to do this one, probably more. Number 20. I gave you 2 right angles here. I also gave you that those 3 sides are the same, which means this is an equilateral triangle, which means it's also equiangular. That's the key thing. That's the key to getting this one done. All of these angles are the same. If they're all the same, then they're each 60 degrees. How does that help me? Well, if that's 60, 60 plus n has to equal the right angle of 90. That gives me n is 30. But if n is 30, 30 plus m plus 90 equals 180. So that's 120 plus m. M is 60. Okay. For 21, I'm telling you the perimeter is 20. I'm also marking these as equal, so if this is 2x minus 5, this over here is 2x minus 5. Now if I add up all the sides, that's 5x minus 10, 2x, 4x, 5x minus 10 equals the perimeter of 20. Add 10, divide by 5, I get x equals 6. Okay. 22, marked this and this congruent, mark this and this congruent. So if these two are congruent, then this and this angle and this angle have to be congruent, so this is n over here as well. If these two are congruent, then the whole angles here are congruent, which is where I'm going to start. If those two are congruent, then this is 50. So we'll say 50 plus, and I'll call these x, because x, I haven't used that variable yet. So 50 plus 2x equals 180. So that angle plus 50 equals 180. Subtract 50, I get 130, and that gives me x is 65. So that whole angle is 65. Okay? And now I know that m plus n has to equal 65, but I don't know either one of them. How am I going to do that? Well, using this triangle down here, I see this is 90. So these two angles have to add up to 90 as well. So 90 plus 2n equals 180. N plus 90 equals 180. 2n equals 90, n equals 45. Well, if n is 45, subtract 45, I get m is 20. Okay? And that's where I'll stop for this video. Next video, we will be jumping into proofs.